Today we're going to talk about how you use the graph to find information. So you should have gotten a packet earlier today, and in that packet you'll notice that you have 3 papers. The first paper is the first set of notes that we're going to talk about, which is using the graph to find information. This page should go on page 102 in your notebook. The second page is going to be the next set of notes that we're going to do, which is x and y intercepts. That should go on page 103 in your notebook. And then the last page is going to be your homework, which should go on page 104 in your notebook. So today, when we start talking about using the graph to find information, basically what you're going to find out is that when you have the graph of a linear function, it can tell you many things, such as your y-intercept, your x-intercept, your slope, and it can also help you to evaluate a function. So remember that your x-intercept is where the graph crosses the x-axis. And the coordinates for an x-intercept are going to look like, in your parentheses, some number for your x value and then 0 for your y value. Your y-intercept is where the graph crosses your y-axis, and your coordinates for your y-intercept are going to look like 0 for your x and some number for your y. For each graph, we're going to find the information that's requested. So we're going to use the graph that's to the left to answer these questions. So the first question it asks us is, what is the y-intercept? So if I want to find the y-intercept, I would go to my y-axis and find where my red line crosses my y-axis, and so that'll be right here at -2. That makes my y-intercept 0, -2. The next question asked me to find my slope. So I remember that slope is, we represent it with m, and that's my rise over run. And so I can tell by looking at the picture that this is going to have a positive slope because it's low on the left side but higher on the right side. So what I have to do to find the slope is I've got to use pretty points. So I can use my y-intercept as a pretty point. Remember, my pretty points are my points that are on the corners of my little squares that make up the coordinate plane. So there's a pretty point there, and there's another one right here at 2, -1. So if I want to find my slope, I would say, okay, I have to go up 1 place, and I go over 2 places. So my rise is +1, and my run is +2. Now the next question asks me for my equation, and so when I ask you for your equation, you always want to write it as y equals mx plus b. So the good thing is we just found all the pieces that we need for that, because our m is our slope and our y-intercept is our b. So you might write this as b equals -2 for part A. So when I write the equation, it's going to look like y equals 1 over 2x. I could put plus -2, but really it's just -2. So your equation for this line would be y equals 1 over 2x -2. The next question asks me for my x-intercept. So if it asks me for my x-intercept, I'm going to go find where my red line crosses the x-axis. And so it crosses right here at 4. So my x-intercept is going to say 4, 0. On part D, it says find f of 2. Now, if you'll remember, when we talked about f of x, and when we would look at something like f of 2, 2 is in the place of x. So what f of 2 means is that our x is equal to 2. So we're going to go to where on the x-axis we have 2, and we're going to follow it down to where we have a point. So we have a point right here at -1, which means that f of -2 is equal to -1. Or remember that you might see that written as a coordinate, and that coordinate would be 2, -1. Because we went to 2 on our x-axis, we said that x was equal to 2, and we found that our y-coordinate was -1. On E, let's make this one f of -4. So if it's f of -4, remember that that means I'm going to look at when my x is equal to -4. So I'm going to go on my x-axis and follow it down to where I have something on my red line, and so that would be right here. So f of -4 is going to be equal to whatever my y value is there. And so my y value there is -4. So I might write that as f of -4 equals -4, or you might see it written as a coordinate where your x value is -4 and your y value is also -4. On number 2, it asks us for our y-intercept, so we're going to find our y-intercept on our y-axis, and so it would be right here at 5. If I want to write that, I might write that 2 different ways. So I could see it written as a coordinate, which would be 0, +5, or you might see it written as b equals +5, because remember, b represents our y-intercept. Our slope is our m, our rise over run. And so if I need to find the rise over run, I have to find 2 pretty points to be able to do that. So I've got a pretty point here in my y-intercept, and it looks like I might have one here as well. So if I want my rise over run, I'm going to go from the point on the left to the point on the right. So I'm going to say, how far do I go up or down? So it looks like I'm going to have to go up 2, and it looks like I'm going to have to go to the right 1, which makes my slope 2 over 1, or I might just see that written as 2. So on the next one, when it asks me to write my equation, I'm going to write y equals mx plus b, but now I know what my m and my b are. So my equation is going to be y equals 2x plus 5. It also asked me to find my x-intercept, so that's where it crosses the x-axis. So I would look at where my red line crosses my x-axis, and it looks like it's about right here. So that appears to be between -2 and -3. So it looks like my x-intercept might be at like -2.5, but remember we write that as a coordinate, so -2.50. On part E, it asked me to find f of -3. So that means I'm going to look for -3 on my x-axis, and I'm going to follow it down to where I have something on my red line. And so that looks like it would be at -1. So f of -3 is equal to -1, or you might see it written as a coordinate, and that would be -3, -1. F asked me to find f of -1. So I'm going to go to -1 on my x-axis, follow it up to where I've got something on the graph, and it looks like that's at 3. So f of -1 is equal to 3, or you might see it written as a coordinate, and that would be -1, 3. Looking at the right side of that page, this talks about, is it a solution? So if something is a solution to a linear equation, then it has to be on the line that's graphed by that linear equation. So all you're going to do is, if it asks you for a particular point, you're going to see if that point is on top of that line. So in part A, it says, does the point 2, 2 lie on the graph to the left? So I'm going to go on my coordinate plane, and I'm going to find the point 2, 2. So over 2 on the x-axis, up 2 on the y-axis. So that's the point 2, 2, and that point is not on the blue line, and so that means that no, this point is not on the line, and we would say 2, 2 is not a solution. B says, does the point 3, -3 lie on the graph to the left? So I would go find the coordinate 3, -3, and see if it's on my blue line. And so that point does lie on the blue line. So 3, -3 is a solution. So it's really nice to be able to tell whether or not a point is on the graph if you're given the graph, but sometimes you won't be given the graph. And so graphing is not always going to be your best way to determine if an ordered pair is going to be a solution or not. Sometimes they'll give you the point and they'll give you the equation. And if they give you the point and the equation, notice that your point always has an x value and a y value. And your equation will always have x's and y's. So what you're going to do when you're given the point in the equation is you'll take your x and plug it in where x goes, and take your y and plug it in where y goes, and then see if it gives you something that's true. So in this particular problem, I'm going to take 5 and plug it in for my x's, and take -3 and plug it in for my y's. So I would have 6 times 5 plus 2 times -3, and I'm going to see if that's equal to 24. If it is equal to 24 on the left side, then that means that 5 -3 has to be a solution. If it's not equal to 24, then that means it's not a solution. So if I work this out, 6 times 5 gives me 30, and 2 times -3 gives me -6. So I have 30 minus 6, and that gives me 24. So because 24 does equal 24, then that means that 5 -3 is a solution. And so if I were to graph this line for 6x plus 2y equals 24, I would see that 5 -3 is on top of that line. In number 3, it says, is the point -2, -4 a solution to y equals 5x plus 6? So just like before, we're going to label what our x and y is in our coordinate, and then we're going to plug those in where they should go in our equation. So the equation was y equals 5x plus 6. So we're going to have -4 equals 5 times -2 plus 6. So that'll be -4 equals -10 plus 6, and -10 plus 6 gives me -4. So because -4 equals -4, -2, -4 is a solution. And if I were to graph the equation y equals 5x plus 6, I would see that -2, -4 was a point that was on the coordinate, or on the line. Number 4 says, is the point 1/2 13 a solution to y equals 5x minus 2? So I start by labeling my x and my y in my coordinate, and then I take my x and y and plug it into my equation. So I'm going to have 13 equals 5 times 1/2 minus 2. So that's going to end up being 13 equals 5 times the half will just be 5 over 2 minus 2. So 5 will not divide by 2, but I can kind of figure out that 5 divided by 2 is going to give me 2.5. So I'd have 2.5 minus 2. 2.5 minus 2 will just give me 0.5. And because 13 does not equal 0.5, that means that the coordinate 1/2 13 is not a solution. Oh, that should say is not a solution. In order for an ordered pair to be a solution to a linear inequality, it must make the inequality true. So remember, inequalities look just like the equations, except instead of having equals, they'll have one of our inequality symbols. So remember, those are less than, greater than, less than or equal to, or greater than or equal to. So you're going to do this exactly the same way. You're going to take your point, find your x and y, and plug it in where they should go. So we'll have 8 less than or equal to 12 times 4 minus 23. So this is going to be 8 less than or equal to 12 times 4 gives me 48 minus 23. And so 8 is less than or equal to 25. So because 8 is less than or equal to 25, that means that 8 is a solution to the inequality. If I were to graph this inequality, I would see that this point either laid on top of the solid line or in the shaded area. And the last one for page 102 is 5 -2 a solution to y is greater than -x minus 4? So I start by labeling my x and my y, and then I plug it in where x and y should go. So I'll have -2 greater than -5 minus 4. So -2 greater than -5 minus 4 gives me -9. And -2 is greater than -9, so that means that 5 -2 is a solution to the inequality. That means that this point would lie inside of the shaded region. The next page is for our x and y intercepts, and so that's going to go on page 103 in your notebooks. So on these first examples, the first thing it wants you to do is to identify the x and the y intercepts and write them as ordered pairs. So if I'm looking at number 1 and I need to find the x-intercept, I'm going to find the x-intercept by looking at the x-axis, which is our horizontal axis, and finding where our line crosses that x-axis. And so that's going to be right here, and that x-intercept is going to be at 2, 0. Our y-intercept is going to be where we cross the y-axis, and so that's going to be right here at -2, 0, 2. On number 2, if we need to find the x-intercept, we're going to find where the graph crosses the x-axis, and that would be right here. And our x-intercept would be at 2, 0. And our y-intercept will be where we cross the y-axis, which will be right here. And that's at 0, 2. On number 3, our x-intercept would be at -1. So to write that, we would write it as a coordinate as -1, 0. And our y-intercept, we would find where the line crossed the y-axis, which will be right here. And so that's actually at -5 on the y-axis. So that point will be at 0, -5. On number 4, our x-intercept is at -3 on the x-axis, so it'll be -3, 0. And our y-intercept will be on the y-axis at 2, so our y-intercept will be 0, 2. On number 5, our x-intercept is at 1, so that'll be 1, 0. And our y-intercept, where we cross the y-axis, will be at -3, so we'll write that as 0, -3. And the last one on this page, number 6, to find our x-intercept. Our x-intercept will be at -4, so we'll write that as -4, 0. And our y-intercept will be at -3, so we'll write that as 0, -3. On the right side of this page, we're going to find and graph the intercepts of the following linear equations. So on number 1, if we want to find our x-intercept, we're going to plug in 0 for our y. Because remember, all x-intercepts are written as a number, 0. So to find our x-intercept, we're going to say x plus 0 equals 8. And so our x is going to be equal to 8. So if I was going to graph that, I would have to find 8 on my x-axis which would put me, let's say, that's 6, 7, 8, so it'll put me somewhere way out here. And then to find your y-intercept, you're actually going to do 0 for x, and that's because all my y-intercepts are going to be 0, comma, some number. So we're going to say 0 plus y equals 8. So my y is equal to 8. So I would go find where my y was equal to 8, and that's actually off my graph on this one as well. So we'll say that's 6, 7, 8. Once you get 2 intercepts, then you can connect them and you've got your line. So this is just another way that we can graph equations of lines. We can graph that by finding the x and the y intercepts and then connecting those two. Alright, on number 2, we want to find the x-intercept. So we're going to plug in 0 for y. So that means we're going to have 2x plus 3 times 0 equals 12. So it means we're going to have 2x equals 12 because 0 times 3 is 0. We would divide both sides by 2 and we'll get that x is equal to 6. So on our x-axis, we'll go to where we think 6 is, which will be about here. Now we'll get our y-intercept the same way. So this time we're going to plug in 0 for our x. So we're going to say 2 times 0 plus 3y equals 12. 2 times 0 is 0. So we'll have just 3y equals 12. Divide both sides by 3, and we'll get that y is equal to 4. So we'll go to 4 on our y-axis, put a point, and once we have our 2 points, we'll connect them. And that will give us our line for 2x plus 3y equals 12. On number 3, we'll get our x-intercept by plugging in 0 for y. So we'll have 6x plus 4 times 0 equals 12. 4 times 0 gives us 0, so this left side is really 6x equals 12. Divide both sides by 6, and we'll get that x is equal to 2. So we'll get a 2 on our x-axis and put a point. And then we'll get our y-intercept by doing 0 for x. So by doing 0 for x, we'll end up with 6 times 0 plus 4y equals 12. 6 times 0 will give us 0, so we'll just end up with 4y equals 12. Divide both sides by 4, and we'll end up with y equals 3. So on the y-axis, we'll go to 3, put a point. Once we get 2 points, our x-intercept and our y-intercept will connect those, and we'll have our line. On number 4, to get our x-intercept, we'll do 0 for y. So we'll say 4x plus 0 equals negative 8. So that'll just be 4x equals negative 8. Divide both sides by 4, and we'll get that x is equal to negative 2. So on your x-axis, you'll go to negative 2, put a point. To get our y-intercept, we'll do 0 for x. So we'll say 4 times 0 plus y equals negative 8. 4 times 0 is 0, so we'll get y equals negative 8. So on our y-axis, we'll go to negative 8. So this is negative 5, negative 6, negative 7. We'll guess negative 8 is down here. We'll draw our line to connect our 2 points, and then we're done. For number 5, to get our x-intercept, we'll do 0 for y. So we'll say 5x minus 2 times 0 equals negative 10. Negative 2 times 0 will give me 0, so 5x equals negative 10. Divide both sides by 5, and we'll get x equals negative 2. So on our x-axis, we'll go to negative 2 and put a point. To get our y-intercept, we're going to do 0 for x. So we're going to say 5 times 0 minus 2y equals negative 10. So negative 2y equals negative 10. Divide both sides by negative 2, and we'll get y equals positive 5. So we'll go to positive 5 on the y-axis, put a point, and then we'll connect our 2 points. And we've graphed the line for 5x minus 2y equals negative 10. On number 6, we've got x minus 4y equals 16. To get our x-intercept, we're going to do 0 for y. Basically, you're canceling out what you don't want. So if we want our x-intercept, we're going to cancel out the y's. So we're going to say x minus 4 times 0 equals 16. 4 times 0 is 0, so we'll have x equals 16. So my x equals 16 would be somewhere way out here. To get my y-intercept, I'm going to do 0 for x. I'm going to cancel out my x values. So I'm going to say 0 minus 4y equals 16. So I'm going to end up with negative 4y equals 16. Divide both sides by negative 4. So my y is going to be equal to negative 4. So I'll put a point at negative 4 on the y-axis, and then I'll be able to connect my points and have an idea of what that line should look like. On number 7, you've got negative 3x minus 9y equals negative 18. To get my x-intercept, I plug in 0 for y. Remember, you're trying to get rid of your y so you can figure out what x is. So you'll say negative 3x minus negative 9, or minus 9 times 0 equals negative 18. My negative 9 and 0 will go away. So I'll end up with negative 3x equals negative 18. Divide both sides by negative 3, and you'll get x equals positive 6, because negative 18 divided by negative 3 will give you a positive. So we'll put a dot at 6 on the x-axis, and then we'll do the y-intercept by plugging in 0 for x. So we're going to say negative 3 times 0 minus 9 times y equals negative 18. So we'll get negative 9y equals negative 18. Divide both sides by negative 9, and we'll get that y is equal to positive 2. So on the y-axis, go to positive 2, put a point. Once you get your 2 points, connect them with your line, and then you're finished. On 8, you've got 7x minus 2y equals negative 14. To get your x-intercept, you're going to do 0 for y. So 7x minus 2 times 0 equals negative 14. 7x equals negative 14 because negative 2 times 0 cancels out. Divide both sides by 7, and you'll get x equals negative 2. Go on your x-axis to negative 2, put a point. To get your y-intercept, you're going to do 0 for your x's. So you're going to say 7 times 0 minus 2y equals negative 14. So you'll get negative 2y equals negative 14. Divide both sides by -2, and you'll get y equals +7. So you go to +7 on your y-axis and put a point, and then connect your 2 points, and you're done. And the last one, you've got -10x plus 15y equals 60. To get your x-intercept, you do 0 for your y. So you'd say -10x plus 15 times 0 equals 60. 15 times 0 is 0, so you get -10x equals 60. And divide both sides by -10, then you'll get x equals -6. -6 will be somewhere about here. Now we're going to do for our y-intercept, 0 for x. So we're going to say -10 times 0 plus 15y equals 60. -10 times 0 would be 0. So 15y equals 60. Divide both sides by 15. And you'll get y is equal to 4. So then you'll go to 4 on your y-axis and put a point. Once you have your 2 points, you'll connect them. And you're done with number 9. Page 104 should be your homework for today. So the first 6 problems, you're going to have to find the x and y intercepts. And then for 7 through 12, you're going to get the slope and the y-intercept, and then you're going to graph them. So on the first 6, you're going to do exactly what we just did on the last 9 problems. And then on 7 through 12, you're going to have to find the slope and the y-intercept of each equation, and then graph the equation. So remember that your equations should be written in y equals mx plus b, where your m is in front of your x, so your m is your slope. And your b should be alone, and that should represent your y-intercept. So if you're looking at number 7, you've got y equals -x plus 3. In front of that, x is a -1. So your slope here would be -1, and your b would be 3. Remember, when you're graphing this, you're always going to start with your y-intercept, which is going to be a +3. So on your y-axis, go 1, 2, 3. Then to get your slope, it's -1, but that's really -1 over 1. So down 1, and then over 1 to the right. Or you could have gone from your y-intercept up 1 and over 1 to the left. And then once you get a couple of points, you'll connect them, and then you'll be finished.